So we got an F14 Tomcat. Right slingshot does not work. So we push the middle button down. See there how it goes two positions? Want it down. Then you hit one of the black buttons and it'll put it into test. Then you got to put the middle button back up to go to the next test. And then that test. And then this test. And then the coil test. And then you use the middle button. You can stop it. See, I can make it stop at the ball popper by pressing the middle button down just to keep it to repeat. Okay. So I got to wait until we get to the right slingshot. And then I'll press the middle button down just to lock it on that. And the right slingshot's like last, so it's going to take a second. It's coming, it's coming, it's coming, it's coming. I know it's coming. There it is. Okay, so I got that button pushed down. That locks it on right slingshot. So the right slingshot should be firing. It's not. Now I checked for power at that using my meter. 34 volts at both lugs of the coil. If you only got it at one lug of the coil, that means the coil's open and the coil's bad. You'd have to replace the coil. But it was at both lugs. So we got power at the coil. So the next thing you can do is, I know that it's up in the special solenoid section on the CPU board, and I know that it's Q71. And what I did is I took an alligator clip and grounded this big transistor tab against just the metal backplane, and it would actually fire this thing. Okay. In fact, let's demonstrate. So I got an alligator clip just hooked up to that Q71, and then I'm just going to take this end and put it against the metal. Hear it? You got it firing. Yeah, you see it? See it firing down there, and I'm just hitting that. You see the spark. Okay, so I know that the power is at the coil. I know that from this transistor through the wiring down to the coil, everything's good. So, but it's still not working. Clearly, it should be firing in this mode, in the test mode, but it's not. So, the next thing we're going to do is use your schematics. I go to Q71 and I start a PIA, which is a peripheral interface adapter, sends a signal to U45, which is a little TTL chip, 7402. It has two inputs on pin 5 and 6. And then outputs to pin 4, and then goes to the little transistor and then the big transistor. The big transistor was the one that we were messing with. So I got my meter, which actually has a logic probe built into it, so I can see the signals. So I'm going to go to U45 pin 5, which is this guy right here, and I'm going to count the legs. 1, 2, 3, 4, 5, right there. Hear it pulsing? That means that's the game trying to fire the right slingshot. Okay? And then there's pin 6 I don't care about, but pin 4 is then the output. And now here it is going in the other direction. So that chip is working. So it's taking an impulse from either pin 5 or 6 and then outputting through pin 4, and we can hear it pulsing. Then it goes to the little transistor, Q70, to the base of that, and we should get the same signal, which is the base is the middle pin, and you can hear we're getting that same signal. And then you get the output pin, which is the one on the left of that one, and you can hear it, we're still getting that same signal. So it's outputting through that transistor and then off to this transistor, the big transistor. So you can see here's the output leg of the little transistor going to the input leg of the big transistor. So the input leg of the big transistor is the one on the left, and we can hear it, but we don't get anything on either of the other two legs. Nothing, no pulse, no pulse. So my conclusion is that this transistor is bad, the tip 102, which is the thing that goes the most common. Put a brand new tip 102 transistor in, and I put it into, it's actually just in display test. And when you have it in just display test, you know, the flippers will work, you know, all the coils will work. Like here's the left, and guess what? Now the right, and now works. Pop bumpers too will work too. You can actually kind of semi-play the game. I mean, it doesn't score points, but you can bat the ball around when it's in display mode. So that fixed the problem. Now what's really interesting is the original tip 122, which is right here. If you tested this with your meter, black, you know, diode setting, black lead on the center tab or on the metal tab or center leg, and then red on either outside, you should get 0.4 to 0.6. This actually tests good. This transistor tests good, but it's not under load. It just goes to show that using your meter to test transistors not under load isn't always the best way. That's why doing the logic probe thing, where we actually trace the circuit from the PIA to the U45 to the little transistor to the big transistors, is really a much more effective way to figure out what the problem is, so you're not just shotgunning and replacing crap. I mean, if I was going to guess, I was going to say that transistor would have been the problem anyways. It's probably would have been the first thing I replaced, but not everybody is so succinct about it, and so draw your own conclusions. So now we can shut this back off, turn it back on, and put the balls in it. Start a game. Take a ball, and look, our slingshot now works. So cool. Another problem on this game was some flashers that didn't work. These little boards under here are the flasher boards. They should look like this with the four. These two outside are 330 ohms. The two inside are 5 ohms, 10 watt, and these smaller ones are 5 watt. You can see on this board that the 10 watt ones have fallen off. If these fall off, it's not such a big deal, but if these fall off, the flashers will not work. So we've got this board, and I've got this one here that's missing 3. So we got to repair that so all his flashers will work.